Now we're going to use the Pythagorean theorem in real-world situations. So something like this. Here I've got a house, and then the premise is going to be like, hey, you got to stand a ladder next to it. So I'm going to stand a ladder next to that house, and then what we have then is conceivably a right. If we had good builders, a right triangle here, right? So now we've got a leg and a leg and a hypotenuse. Tenuse, right? So in these problems, what we're going to be given is two of those values, and then we solve for the third. So we get another chance to practice with that Pythagorean theorem. So in this case, let's say the hypotenuse was 13, and this leg was 5, and then this one we don't know. We'll just call it b for now. And to show you that then, so I've got a squared plus b squared equals c squared. That's our Pythagorean theorem. We know that. We got that down. Now we're going to substitute our values in. I know that one leg is 5, so that's 5 squared plus the other leg we don't know. It's b squared. And then the hypotenuse, the longest line or the line that's opposite the right angle, is 13. Now those of you that excelled at those triples already know the answer. Right, but if you were still wondering about some of those triples, let's look at it and see how this works out. So I've got 5 squared is 25 plus b squared equals 169. We're going to subtract 25 from both sides. Let's get a different color now. And when we subtract 25 from both sides, that leaves us b squared equals 144. In manufacturing, that is a gross because it is 12 by 12. So then we can take 144 and find the square root of that, square root of this. We know the square root of b squared is plus or minus b, but because we're talking about a length, we're going to use the positive version. And then the square root of 144 is 12. And I did not put any units on it, but if I did, let's say that's feet, b feet. Which means the height on the building then is we can reach up to 12 feet on the building. So this is just using the Pythagorean theorem and then putting it in the context of real-world situations. It's another building. So now I've got this building, here's my scenario. One of the things that really helps with this, and eventually you may get a problem that does not have a picture. If there's no picture, please draw. Oh, this purple, come on, dude. We need you now. Draw the picture. It's much easier for us to visualize something if there's something to see, right? So if we didn't have this, draw the picture. Give yourself something to work with. So in this says, write an equation that can be used to find the length of the ladder. We're not sure what that is. Then solve and round to the nearest tenth. So we're going to use the Pythagorean theorem. That's what the lesson is. So that is a squared plus b squared equals c squared. Now going back to the values here that we have, here's our right angle. So the two legs make the right angle. So I'm just going to put an a there and a b there. Across from the right angle is the hypotenuse. It is also the longest length there, so that is our c. What we don't have, we will figure out. So we have 8.75 squared plus 18 squared equals what we don't know, c squared. All right, so this is where consult our handy dandy calculator. 8.75 squared equals. Now this asks us to round to the nearest tenth, so I'm going to consistently do that through the problem. This says 76.56, which means I'm going to turn it into 76.6. Plus 18 squared. 18 squared is 324, and that equals c squared. Now we're just getting the sum of those two legs that have been squared. So I got 324 still in my calculator plus 76.6, and that gives me 400.6 equals c squared. That's a good number. So this is going to work out pretty close to 20, and we should expect that. So now I'm going to take the square root and the square root. Now the square root of c squared is c. 400.6, I still have my 400.6 in my calculator. I'm going to hit second function and then the x squared button, which is gives me my radical, and enter. Clear. 400.6. 6. Enter. And that gives me 20.01. But this says nearest tenth. That's not going to change that. I'll take the 1 off. So the side length that I have here is 20 feet. So this length here is 20 feet. All right, all with the Pythagorean theorem. Let's do this quick. We can do one more real quick. Let me flip over the problem. Let me erase my work. Same situation, kind of, except this time we're fishing, and we're checking to see how deep the water is. I've got a fisherman here. His line is going down into the water. It's 15 feet to, no, the depth of the, so the line doesn't go straight down, it just kind of hangs beneath the boat. Then it's about 6 feet difference here. So in that, we're just going right back. Pythagorean theorem, there it is. B squared plus C squared, no, equals C squared, my bad. And then we're just picking out the values again, right? Let's make sure we identify it right. I've got 2 legs, they make the right angle. I've got a hypotenuse, it's opposite. I've got an A, a B, and a C. Easy to find. So then let's put the A in here. I got 6 squared plus B squared equals 15 squared. I don't see a Pythagorean triple there, but let's keep going and see. Maybe we'll discover one, maybe we won't. 6 squared is 36 plus B squared equals 225. Just simple equation work now. Minus 36 minus 36. And I get B squared equals, all right, let's ungroup that. 15 minus 6 is 9. Ungroup this. 11 minus 3 is 8. And once here, I think I've seen that before. I think that's going to be 17. But let's check. If my memory serves right, so now we're doing this. I need the square root of this and the square root of this. And we do that solely because that's how we turn this into just b. Because the square root of b squared would be b. So second function, x squared button, that gives me my radical. 189, enter. I was completely wrong. That's right, 17 squared is 289. So 189, the square root of 189 is 13.747. I put the extra 7 just because. Now for me, the variance on this is, if you had 13.7, I'd be fine with that. But if we go a little bit further, this 7 turns this into a 5, then this 5 would turn that into an 8. Either one would be acceptable. So in essence, we'd say that the depth of that line, where that fisherman is fishing at, is 13.8 feet. At this point, it's okay to use your approximate equals because it's not exact. Either one is fine. If you put equals, that's okay. But the truth is, it is approximate. So that equal sign would be just as well, just as good. Okay? Good luck.